Yeah. Whew. That new car smell. Yeah. And you get hydraulic lines and all this other stuff. So we'll start the tour here and work our way back. Feel free if you need to sit down.
Oh, thank you.
Yeah. Yes, and those seats are fully operational too.
Up there is where you can go back down on a minute.
Yeah, the Stratospheric Observatory for Infrared Astronomy. I kind of like doing this tour. It's like two tours in one. I'll talk a bit about the airplane itself. It's unique in its own right, as well as the telescope mission. So the aircraft is a 747 SP. That stands for Special Performance. It was not designed strictly for NASA. It actually spent 20 years flying with civilian airlines. Back in the 1970s, many civilian airlines had a requirement for a larger plane, could carry a lot of passengers long distance without refueling, specifically like East Coast of the United States over to the Middle East. And so they came up with the 747 SPs. So after flying with civilian airline until about the end of the 90s, around 1999, NASA bought it. It's not the first time that a plane has had a telescope on board. There's a little sign, a little plaque up here showing different size aircraft. There was a couple of small ones, the Learjet type. There was another Convair plane. Flew many years on a C-141A transport plane, civilian version of the 141 cargo plane, and then now on SOFIA. So all of these signs and plaques up here, these are all put up by NASA. This isn't something that the Air Museum has just done. So this is how it flew with all of these. And if you want on your way out after the tour, any of the ones that have QR codes, those QR codes do still work. So, so the SOFIA mission, it was run jointly between NASA, the American Space Agency, and the DLR, the German Space Agency. The aircraft itself belonged to NASA and run by NASA. The telescope belonged to the DLR. The telescope is not actually on this aircraft, but that's okay because even if it was, you wouldn't be able to see it anyway. It would be behind that big pressure bulkhead back there, and I'll explain a little bit more about that when I get back. So as you can see here, this kind of looks like a NASA command center for a space flight. And that's, I'm sure, where they got the basis for how they laid everything out. So what we have here is what's called the EPO console, the Education and Public Outreach console. NASA gets their funding from the public, and so they were very much with public outreach, a lot of education. They could do different experiments. They would have educators here. They would have postgraduate students, etc. If you want to move on back here, so here we have the mission director and mission director 2. The mission director is in charge of the entire aircraft, the telescope, and the whole mission. Over here is where the telescope operators were. Right here is where they could put a different console depending on a different experiment. People often ask, why put a telescope on an airplane? We have the James Webb Telescope, we have the Hubble Telescope. Well, okay, a couple of reasons. If you have a telescope up in space and something breaks, it's not too easy to fix. Happens on a plane, you can land. Also, if you want to try a different experiment, well, you can just land, put a different experiment package on there. Like I said, you can put another console on there, right here. And then we put the experiment package here using the same infrared telescope, and would just, monitor it or adjust it in some other, different way. And they would have all the avionics packages that could slip into these bins over here and all the wiring. So this is set up exactly in conjunction where the telescope is. So in other words, the telescope is on the other side of that pressure bulkhead, and it would be lined up in the same fashion as you see here. There's a door on the other side that opens up to the atmosphere. That's why the pressure bulkhead. You have to have the telescope opened up to the atmosphere. Two reasons. One, because you want to have it same temperature. You don't want to get any kind of condensation on there. but mainly because there is no substance known to man that will not hinder infrared rays. No glass, no plexiglass, whatever. Anything would hinder infrared rays. So it has to be exposed to the atmosphere to get better readings. So this would be set, and when it was in place and the telescope on the other side, even though it weighed like 2 tons, you could move this with your fingers. And it sat in like an oil bath and also on these air cushions, some of the cushions over here. And if you want, after my talk here, you can come back and look at some of these models, get an idea of the size of the telescope, and also what it looked like when the door was open over here. I guess to finish up, when they were given the training to the docents and explaining everything, they did the same thing, gave us the whole tour and such. And then we're on our way out, and I said, hey, well, wait a minute. I'm pretty observant. I noticed this dot back here commemorating the Wright brothers' first flight. I mean, that's admirable. That's a very significant thing, but what does that have to do with the flying telescope? They said, oh, because the Wright brothers' first flight, the distance from the nose of the plane to that sign is the distance of their first flight. So it kind of puts things in perspective. We've come a long ways. And if anybody has any questions, I'll be right over here. Feel free to look around. Also, too, over in our space gallery, there's a big display for SOFIA and videos and some of the equipment and everything over there, too.
So the telescope is 2